network security group. Pretty primitive, 5-tuple source, destination, port protocol type thing. And everything in cloud is like hierarchical, really. So you have like groups of things, and then within that group of things, you have more groups of things and more groups of things. So these foundational components, one thing that's important to know is like, okay, when I create a subnet, I have to like reference the unique ID to attach it to a VNet. Like it's part of a VNet. They're tightly coupled. But when I make a routing table, a custom routing table, I can add that to subnets and I can add that to VNets. Got something?
Somebody's at the door. If you could. We have another visitor, I guess.
Did they ping you?
Chad did. Apparently they pinged Chad.
Charles, Chives, whatever, what's your butler name?
Chaz.
Alfred.
Alfred.
So UDRs, you can add those to subnets and VNets. These user-defined routes. And then you have these network security groups, and these are more tight. So you can actually add these to VNets, subnets, and I guess the virtual NICs on virtual machines. I guess that's about the 3 places you'd see them. So they're more, I mean, in practice, they're more focused towards like closer to the application, closer to the workload, where, you know, a subnet might have many things in it. And a VNet definitely has many things in it, many applications, many services. It's not just one app. So all these things are basically core resources, and they are in like every design I've ever seen. And they are foundational. They haven't changed in forever. I mean, they've basically just been there statically. I mean, I guess the one thing that changes is the limits. So you can create more routes, or, you know, more rules in an NSG, or more subnets. So that, you know, keeps going up to maintain competitive nature of cloud and scale. So plowing right ahead. So when I create a VNet, and this virtual network, I don't want to assign a gigantic, a CIDR range. I don't want to, assign a super small CIDR range. Maybe something in the middle. But then I got to create and carve out that CIDR range into subnets. So when I create a subnet, that subnet is going to automatically get a whole bunch of system routes. And this was really confusing to me when I first started working in cloud, because I was like, what the heck? I want to have control. I want a router. I want to see a forwarding information base. I want to see the routing table, and I want to be able to control, exactly how packets are flowing. And the thing is, Azure, there's abstraction. So you have an underlay where they have like a fabric router essentially on their backbone. And that does a whole bunch of secret squirrel routing that you are not privy to, you don't see. And on top of that, I guess what would be considered the overlay, or the, just kind of the surface that you see in Azure, that's your VNet. And it has to basically inject these things in here to give you the outcome that you want. Because if you're doing this yourself on a regular network, okay, you got to buy circuits, you got to connect sites, you've got to, do layer 2, layer 3, you have routers, you have to decide what routes to advertise, what routes to receive, actually build the adjacencies between things. It's a place that I never want to be at again. I left that world a while back, and cloud is much nicer and more elegant. So what do these things actually mean? So the first one, this virtual network hop, like you can actually replace the prefix address space with the CIDR range that's present there that you assign. But this is basically to make sure that everything within that VNet, all your subnets are talking. You have the private connectivity between all the resources and all your subnets. And the next thing is a default route, quad 0 to the internet. And I guess you could think of this like, so we all have a home network, we have a router at home, and whenever we set up that router, either you assigned a private IP space, or it gives you one. Usually it's like 192.168.1.0/24 or something. And then if within your home network, you are trying to get to something that you don't have a route for, or it doesn't know about, there's like a default. It's going to send you out to the internet for everything else. So it's like everything you know about, and then it's okay, as a last resort, we're going to send things here. And then you have these other, so discarding RFC 1918 in that one range from 6598. So these are private IP ranges. And I mean, I guess the reason, I should have probably looked this up, but I guess the reason why I would discard these by default is you don't want to try to route these anywhere else. You want to just not route private IPs, large ranges like that out to the internet. There's security and many other reasons that you may not want to do that, but that's a default. So yeah, we have these system routes that get created automatically to make our lives easier. So what about the behavior? So say that I want to get to this 10.5.1.20. I need to get to that IP. And these are all the routes like in my route table. And really, all four of those would work. Like they are, that IP is within those ranges for getting there. But I have four. Which one is it going to choose? Or how does it choose? So the way that actually all the cloud providers really work is they're going to choose the longest prefix match, which is basically to say the most specific route. And it really has to do with a longer subnet mask, more bits to the one side. So that is the most specific route. I mean, it's a /32, it's essentially a host route, really. So of course, that's going to be the best route to choose. But there are a lot of cases where you're going to have the exact same route that's learned from different places in a routing table, and a tiebreaker comes in. So how would, if I had that same route from different places, how is Azure going to make that decision where to actually send that traffic? Well, it's going to prioritize. So first, it's going to look at my, the routes that I've defined, those custom user-defined routes. That's going to be the first thing. And then it'll look at anything like learned BGP routes. That's going to be second. And then it'll fall back to the system routes as the last. And this isn't for every service. So like Azure has, like take PaaS services, for instance, like Azure has like private and public PaaS. Public PaaS is just different, but this would still be applicable to like private PaaS. So say I have Snoop Dogg in these slides because again, it's networking's dry, keeping people engaged sometimes it's been hard over the years.
West Coast company, I'm assuming.
So Snoop Diggity Dog, he lives in, I didn't know this until I put this slide together a few months ago for something else, but he lives in Country Estates in Southern California. It's a great neighborhood. It's a lot better than the neighborhood I live in, coincidentally. I think it's like 30 minutes from Hollywood Hills or something. So,
You're doxing him?
huh?
Does he know you're doxing him?
No, but if he did and he decided to call me out, I would welcome it. So Snoop, it's a block party. His neighborhood, he likes he's got his crib, that subnet. Remember, we tied subnets to houses. And if he wants to go to a party somewhere else in that neighborhood, he's open to go and, have fun. Sky's the limit. So what happens though when Snoop hears about another party in another neighborhood, another VNet? How do you connect these suckers? Okay, so he hears that Willow Heights has a poppin' party. He needs to get up on over there, because it's Snoop and he's all about the parties. So he gets on his Snoop bicycle or his Snoop scooter or whatever he rides around, and he's gonna go over to this other party. So what does that look like? So on the left, we have this Country Estates, the neighborhood he lives in. On the right, we have this other neighborhood, Willow Heights. They're both in the city of Diamond Bar. Yes, that is the name of the city. Legit. So how in the Azure world, so usually the outcome that you want is you have like a subnet that has, or a group of subnets that have, composed like an application or a service that need to have connectivity to subnets in another VNet. But you can't do this at the subnet level. You have to connect the VNets first. And well, Yeah, you want to connect the VNets first. And there's a few ways to do this, but the way that you're going to see most in the wild is, first of all, you're going to see VNet peering, which is basically saying it's an easy button. It's like, okay, we have all this abstraction, and Microsoft actually makes this so much easier than some of the other clouds. Like I set up, I'm not going to name the cloud because I don't want to cloud shame, but I set up VPC peering in another cloud a few weeks ago, and it made me really appreciate the way Microsoft does this. It's just so easy. So VNet peering is awesome. And you can think like, Snoop Dogg, he wants a nice, smooth road, maybe multi-lane so the traffic is nice and, it keeps going and he doesn't run into a traffic jam like Mr. Waddell did on the way. And then the next thing that you can look at, so you have VNet peering, one VNet talks to another VNet, Microsoft service. The other way you can do it is in the form of gateways. Now I have VPN gateway in here, but there's a lot of things you can put in a VNet, even like third-party stuff that will facilitate this connectivity for you. But VPN gateways or site-to-site VPNs have been very popular, especially when you consider connecting on-premises networks. So this is more maybe like back roads. It's over the public internet, IPsec. A lot more setup is required, as in you VNet peer something and you can do it in like a minute. You set up a site-to-site VPN, it's not a minute, it's a lot longer than a minute. You have a lot more resources involved, it's more in-depth process. And think of it like bridges and tunnels on the back road in our little Snoop Dogg scenario. So Snoop Dogg always chooses VNet peering because he likes the easy button. But we're going to see later on, sometimes the easy button isn't always the right button, and VNet peering can turn into a mess. Which leads us to planning for scale. So I remember like one of the first Azure environments I ever set up, it was just a bunch of VPNs actually from a few different data centers. And then when we discovered VNet peering, and it was actually at that point, there was like not cloud teams so much. It was really just an app team at this place. And they set up, they went like ham with the VNet peering. And we will get into that in a second. I guess one of the things that I think it's important to understand, like sometimes you run into like a limit. I wouldn't call it a limitation. I'd say it's there by design for many reasons. But when you have a VNet and another VNet, they cannot transitively route. So basically what that means is I have VNet A and VNet B. I can VNet peer these together and exchange routes and everybody's happy, all is well. But if I wanted to say, okay, I want to connect VNet A through VNet N, and I want to do it through VNet B. I want that to be an aggregate because maybe I have some shared service type stuff in that VNet that I need to send traffic to. There's many reasons. Transitive routing is not available in that VNet, as is. So what that typically costs, a lot of the environments I see today anyway, still. Oh, and also, you can't VNet peer to on-premises. This should be obvious. But I remember one time I actually took a support, like there was a thing where folks were trying to make this happen and there was no buttons in the UI, and no matter what they did, they could not VNet peer to a device that they owned and managed in a data center. If you want to do that, it's, over the internet, site-to-site VPN or, an express route. So that's one thing that you have to keep in mind is it's not just your world in Azure. A lot of times there is, technologies outside of Azure, whether it's the intellectual property in your data center or just other third-party services that you have to inject and integrate into a given design. So what this ended up looking like a lot of times is like the more, I would say that you always start, like when I was going into a lot of these environments earlier on, you always start out with like, okay, we have 1 or 2 VNets, maybe 3 or 4. We don't have a ton. But then it snowballs really quick, and before you know it, you do have a ton. And like some of the companies I talked to today, honestly, like, they range from like, maybe a few hundred to thousands of VNets. It's pretty wild, which is like the point where you look at services like what we offer, like where I work, when it becomes that type of scale, and especially like if going outside of Azure is a big deal. So this becomes problematic for a lot of reasons. And usually what happens is you have to go back and you have to do some sort of re-architecture. And really, it's like, I don't know why I put this in here because now I'm hungry. Spaghetti is a spaghetti mess. So if you think of like each one of those noodles, it's like a different network construct, and it just becomes untenable to manage because it's a combination of like not understanding the way your traffic flows, not being able to control it. Maybe you have design like A and design D, and they now need to talk, but you need to limit that communication. Like there's so much that goes into this that can be problematic when you're taking that everything peers with everything approach. And I know that they've upped how many tiers you can get. I think it's like over 300 or 400. I don't know if you know, Waddell.
I think it's 500 now.
500, that's good.
500, maybe 1,000. I thought they.
Oh, they might have upped it again.
It was 500 for a while. So.
Yeah. So yeah, I mean that's progressively going up. So let's.
So per the sub.
VNets.
Per VNet.
Each VNet can have that many peerings to other VNets.
Okay.
So what ended up happening, like it was sort of a best practice. This is kind of a best practice design, and all the sort of that transitive routing thing that I just kind of talked about, that's the same thing for like every cloud pretty much. If you deploy just the VNet, and you can think of like, Barry, you can think of like a VNet almost as like a VLAN. It doesn't have that, it doesn't have like forwarding engine, hairpinning, aggregation of routes, and all those things that you can control. Like you have to add more on top of it to make those things happen. So this hub and spoke architecture became kind of like a standard. And then honestly, in most environments I see today, this is still what is being used. And I mean, I would honestly recommend, if it's meeting your requirements, we're going to talk about vWAN and route server and a few of those things in a second. But if you have a design that's designed well, it's consistent, and you know what the scale is going to be, there's really not a lot of reason to, I think, deviate from this design too much. So typically what you have is all the way on the right here, all the things that are like application workloads. So you have like VNets that hold applications that make your business money. Those are going to be attached with VNet peering back to a regional hub, which is where you have like shared services. Think like maybe a DNS product or an automation product, or
You shouldn't call them shared services, man. That's a very hairy word around here, right? I'm just kidding.
DNS gives me PTSD.
yeah, so does every other network engineer for sure. So what happens here is you have this gateway subnet, and you do have an option. I forget what it's called, but you can basically check a box to allow things to transit through the hub. And basically all that does is allow on-prem to come in and then route to your spokes. But that still it's still not like a full-blown router to where you have the logic. You can't set up, routing protocols. You can't do the same advertisements that you need to do to control traffic. So I still couldn't route VNet A to VNet N just through the hub alone without anything else. So usually what tends to happen is a lot of companies will inject another, well, there's really two options here. You could either inject like a network virtual appliance, I see a lot of Palo Alto and a lot of Cisco CSRs, which I'm starting to hate those these days, but some sort of appliance that actually has route forwarding functionality built in. But even that's hard, because then you have a thing where you have to do spoke to the appliance, and you can run IPsec and then run BGP atop everything, which has its own scaling challenges. But this will help you with your spoke to spoke, and you can even route all the way back to on premises with your big ASR or Cisco router, and then route back up. But I hate that design. I've had to live in many environments that had that design. And it's just like, if my destination is something in Azure, I don't want it coming out of Azure. I want it to stay in Azure. That's usually the best case scenario. So things about this design though, and again, like if you have this design and it's working, great. You don't change things up if it's meeting your requirements, but there are, as cloud is just sort of blown up, there's a lot of big companies that have a lot of networks and just they have huge environments. So you start hitting a few things. Like one thing is manual configuration. Well, I say manual, but just I probably shouldn't have used that because you can automate these changes. But I would say different changes in different places, whether it's on the subnet route tables, within the VNet, or configurations in the hub, configurations on an appliance, configuration on-prem. Like sometimes some of these environments are set up in such a way that you have to change things pretty much everywhere. Maybe there's even 2 or 3 layers of firewalls involved, who knows? So complex routing between the hubs and the spokes. And again, like you want, I like to keep the flow of traffic as simple as possible while meeting requirements. And this can just get sticky when you have all these different things. And in so many different areas that are almost decentralized where different things can be configured that can like mess up the whole chain of, the packet walk. And then this is a big one, heavy reliance on peering. We already talked about that, although the bar has been raised, but if you're 1,000 VNet shop in a single region, a single regional hub is not going to cut it for you unless they increase that number again from 500. So running, and it's not just the peering, like there's, everything in cloud has limits. NSGs have limits, route tables have limits, subnets have limits. You can add, so many routes, so many rules, all these things, there's limits. And oftentimes you won't, unless you're doing some kludgy stuff, you're not going to run into a lot of those limits usually, but it does happen. Again, decentralized network policies and security, the more, and I wouldn't say that this is completely decentralized, but it's not centralized either. It's kind of somewhere in the middle, I suppose, probably trending more towards decentralized, but the more of the core, it's like your core network. You don't want all these things to be decentralized in so many places. And, because what it usually leads to is inconsistency in sort of snowflake designs that you can't automate. And it just becomes, it kind of replicates the mess that we've built in data centers over the years. So you really want things clean, you want them consistent, you want them meeting requirements, and you want to scale, and you want it simple so that you can automate it and do it the same way sort of every time based on some pattern. Increasing, as you add more spokes, again, it makes this regional hub a gigantic bottleneck. And it's complicated it's always complicated to integrate on premises depending on the on-prem environment and the tech that you have in the data center. But yeah, this major challenges here integrating on premises usually. So one thing that's really important. So like every once in a while, I've had this happen a few times in my career where we come to this like clean slate where we're designing like Azure 5.0 with a shiny something, it's got like a gold star with all of our best design patterns and all these things that we've like learned, all, the mistakes that we've made because we didn't know. We have all this knowledge, we have new technology available to us. It's a nice clean slate. And I see it happen so much where things come in and they get rushed. People try to rush things, and then they end up making some of those same mistakes that they did before. So asking good questions is always a really good idea. So the first thing is like, is on premises a factor? Which 9 times out of 10 it is, unless all your money-making stuff is in cloud and you don't have your own data centers and all your IPs moved, your intellectual properties moved to the cloud. Most of the time there's some on-prem involvement though. Do you have a lot of VNets? Again, and I think the more important thing, and it's so funny because this is different in like, I've probably talked to like 100 companies about this over the past few years. What thing in their business, what is the event that happens that makes that company create a new VNet and why? A lot of times there's not a lot of control around this. It's like, okay, here we did it because this department requested it. Here we did it because this whole line of business or this acquisition, and you really want to keep that consistent. And you don't just want to be adding new VNets like crazy. Like having some structure around this is I think it's pretty pivotal.
What would you recommend?
As few as possible.
Because I was like, I have 2 answers in my head, but I was
Well,
like, I was
so-
curious on what yours is.
And the problem is it goes both ways because if you have many, you never hit those limits. But if you have few, then you always hit those limits. And then you have to spin up new VNets, and then you have to worry about VNet A talking to VNet B transitively. And
So like to put it this way,
Put on Kubernetes.
well, you waste so many IP addresses per VNet.
I actually had 2 slides in here about IP addresses, but I didn't want to go deranged. I just like lose my.
I
My
don't,
A little bit on BGP.
in my mind, everything should just be sat. Everything, an app should get a VNet, and it shouldn't be peered to anything. And you just have to do everything over the internet.
That is the guiding principles of cloud to begin with. When it first,
Right.
yeah,
And then they introduce private link and screw everything.
the internet's dangerous, so you don't want things going over the internet, right? It's a danger zone. No, but like think about it like, okay, if you have a single VNet for a single application and you're a large enterprise, probably not a good idea. But if you have like one VNet for like an entire business segment of a big company, again, not a good idea. You're gonna have way too many applications and stuff running in that sucker. You're gonna hit limitations quick. And the happy answer is somewhere in the middle and doing it consistently. Next thing is, do you need to integrate with third-party technologies? And honestly, the more that I've seen this around the wild, the more that I really appreciate just the few times where you can just use that cloud-specific stuff for the application. It makes it so nice because everything's so tightly coupled. Like Azure built all these services to work with each other. And it's just so nice and elegant when you don't have to inject a whole bunch of, the security organizations, like all these tools and services. Because, I mean, with all the stuff that a packet has to go through, all these security things, it's, poor packet. It's getting beat up to death. So just knowing like when you need to inject those, where you need to inject them, and why you need to inject them, which leads us to this next point. What are your security requirements? And I mean like in writing, because one thing I've learned in the past is just because security says something is a requirement, doesn't mean that it's actually a requirement. And a lot of times it can't be shown in writing, and you really have to dig in. And it's really important that you dig in, not just for, your sake or security's sake, but for the infrastructure that you're building, because it can really nerf a design if you do I've seen some strange things done in the name of security. And then you just want to make sure that they're there for a good reason. Because if they are, then great. But if they're not, let's have a conversation about it and dig in.
Not unwound by budgeting.
So BCDR, disaster recovery, high availability, all these things. Cloud's different with high availability. Like in the network world, we have like router A and router B, BGP adjacencies, like maybe CMP or something. And it's like, okay, one router goes down, the other one's carrying the load. But in cloud, maybe I should name this environmental redundancy instead of high availability. Because like high availability in cloud is data centers. So you have like a region, and then you have pockets of actual physical data centers within that region. And to become highly available, those regions are what you want to use multiple of. And Azure is even different here. So Azure actually makes that easy because like some clouds are very fault tolerant. And if you create a subnet, that subnet is only going to work in a single availability zone. Azure does some funny layer 2 stretching tricks or something. I don't really know. I wish I could see their underlay, but they will span subnets across all the availability zones in a given region, which is really unique. And I think they're the only cloud that does that. I think AWS doesn't, Oracle doesn't. I don't know about Google, but yeah, pretty cool. So high availability disaster recovery, and then this is like the wild card of wild cards, because this is like a problem many places, but who is responsible for what? Because when it comes to networking, I've seen it in so many different ways. So you can have like the network team that just grabs a big CIDR range and says, here you go. And then the cloud teams go off to the races. Or you can have network teams that are actually really involved where they do all the routing and control from the VNet level, but then they will actually give smaller blocks of CIDR ranges to the app teams to use structure as code, applications, and they control subnets. It varies, but the point being is, trying to ensure consistency as much as you can, because efficient design is like, it's hard to do it without consistency. If you're not consistent with your architecture, you're really screwed. It just gets out of control and snowballs like so quick. So just understanding these things is really important, having these things defined. And that leads me, I won't spend too much on this slide, but the future of Azure networking. Azure's definitely, their account teams are pushing vWAN pretty hard. I've prototyped this a few times and done migrations both onto vWAN and off of vWAN. And it's really awesome, but with some challenges, I think. And this may have changed recently, but integrations with like third-party stuff, like I think I did one with Palo Alto's, and it was not like, we had Microsoft and Palo Alto on this thing. Neither of them could figure out why stuff would not route. It was honestly a nightmare, and we never did get it working. We ended up dropping in like Azure Firewall. But the problem is that company ended up not even using vWAN because Palo Alto, they built their whole company using Palo Alto pretty much, and they wanted to keep using them. So, that's how,
How long ago was that?
not more than a year ago, but probably close to a year.
It's come a long way in a year.
That's
They're
good.
getting more and more partners.
Yeah. Well, one thing too, they have a massive reset button on that sucker. So if you mess it up, it's like, hey, I can click reset and it's just going to wipe it back to default. If something has that in there, it got put in there for a reason. It's because some people needed to reset a bunch of things many times. And so, I would say that it's not technically a beta product at this point. Like, it's definitely getting there and solves a lot of problems. But I do believe it is the future of Azure.
Sure.
This is going to be a huge thing. Each cloud provider is sort of rolling out their own flavor of this. And really where the benefit is first of all, like scaling out those limitations, making it easier to connect regions, like we were talking about earlier, making it easier to peer and connect spokes across regions within the same region. All the transitive stuff is pretty elegant. And being able to connect site-to-site VPNs, their VPN service, it kind of brings in, like, okay, we know a lot of organizations out there, they have on-premises stuff, and that's not going away anytime soon. They need a smooth way to integrate it, and there's your play for Azure vWAN. And then you have Azure Route Server, which I still, for the life of me, can't understand how the pricing for this thing works. And the thing I don't understand about the pricing, and I'm sorry to pick on Azure a little bit, but this is like a control plane only service. It's actually not doing anything in the data plane, and it's like more expensive than data plane products. It gets very pricey, but it does do something really amazing. So basically, if you were to, so historically, if I put like an SD-WAN vendor or a firewall or something in my hub, it does not, so the routing that Azure does under the hood, like I think the black belts at Microsoft call it the Azure Fabric Router that's in the underlay. So all the routing and everything it keeps track of it doesn't know about things on that NVA, like on that firewall or on that SD-WAN fabric. They don't know about routes, and you have to do all this static craziness to make things work right. And we all know that static routes are evil. Never use them unless you absolutely have to. And you want dynamic routing and you want to BGP the whole world. That's really what you want. So what Azure Route Server does is it enables you to actually dynamically propagate routes via BGP from that, I wonder if that's the right word, that underlay fabric router that's in Microsoft's backbone, and plumb that to all your other stuff, which is extraordinarily useful. And it's probably like such a high value that's why they're able to charge for it. I don't know. It's
Probably used by Fortune 500.
Yeah, and it's a private, I believe it's a private, it's a private PaaS service too. So you set it up right in your own from VNet. And then the last thing is express route, and this is still going to be I would say that with vWAN, you're connecting your remote offices and things like that back to the vWAN. But for those high priority, high value targets like data centers, where you have a lot of data, you're doing migrations, you're doing lots of stuff, and you need, like as Daniel was talking about earlier, like my preference would be going over the internet for everything too, but sometimes in such large companies, there's such a combination of brownfield and technical debt. You don't know what you don't know, but you are still on the hook for connecting to the cloud and migrating things. And you're sort of figuring it out honestly as you go along, which can be challenging. So having that express route keeps things private. It's almost like a private internet connection or a circuit between, usually I think they have a dedicated express route these days, like an actual physical circuit to their rack if you go in a colo, but usually it's through a partner service where you set up an express route, you have a buyer side, seller side tag, and then you have a device on your side, and then you have the gateway and that virtual WAN hub, and then your traffic is passing fast, highly available, more reliable, more technically advertised as more reliable than internet, which at this point, I don't know. So yeah, a combination of these things, especially when you have large enterprises that have lots of different types of things, are definitely going to be a pivotal part of the future.
Virtual WAN is a tree. It's like EVN or Express Route. They're just ways to connect. To Azure.
Yep. Connection manager stuff. Yeah.
Just connected.
Yep. And that is actually all I have. I have this podcast that Daniel Waddell's actually been on before, where we dug into Kubernetes like crazy. So if you want to check it out, if you like it, give it 5 stars. And if you don't ever get a chance to listen to it, make sure and log in and give it 5 stars, and everybody wins. And that's all I got.
Did you get into Kubernetes and Kubernetes?
Nested Kubernetes.
He's got Kubernetes and
Now they're doing stuff like deploying like VMs in Kubernetes clusters. And I remember the first time I saw that, I was like, what?
Right. They now do have Kubernetes in Kubernetes. There's a product called Loft. It's virtual Kubernetes clusters inside of a Kubernetes cluster.
I just still don't.
I'm sure there's some really compelling reason.
And your mind is limiting yourself.
No, I just don't.
Virtualizing on virtualizing.
What it solves is the need for sandboxes, where somebody needs a cluster to just test something, and then they have to go through all the procurement and the deployment, and then like the setup where Loft is just like you click a button, you have a virtual Kubernetes cluster, and then you click another button and it goes away. That's the point.
One of the things Microsoft discovered with
It's pretty cool because it's distributed.
Those companies are setting up VNets, period VNets. And there's.
And then you're like, I'm gonna add this one in.
But they do them all.
And now
And so
I'm just gonna.
virtual WAN, we lose a lot of that control of all those peers.
So I'd be like, how hard?
It's just managed and handled for you, whereas Microsoft's virtualizing that underneath and then traffic shaping everything.
Bad boy. Someone's doing all right.
A pleasure to be here.
We tend to find some
The
grub.
good thing about Microsoft is they throw in dog food. I know they use Route Server for Teams. Internally about that a while back.
There's all of it. There's
Not
all
planned for that.
everything you can do.
Yeah.
You can,
I always like come down here with the.
Hotmail is a big portion of that dog food. Now it's Office 365.